It's used in our agriculture, it stabilizes economy, increases crop yield, and makes everything grow faster. There's no problem with it, right?
Wrong. Fertilizers cause runoff, which leach into the groundwater and more commonly our well water, causing high nitrate concentrations.
Wait, like nitrate, the NO3 molecule?
Well, yes and no. Nitrate in fertilizer is more commonly the inorganic nitrates such as potassium nitrate and ammonium nitrate. They are highly soluble.
But if they were highly soluble, wouldn't you think they'd absorb into the soil or the plant organisms faster?
No, because they're more attached to the water molecule than they are to the organism. So they'll tend to stay in the water than go into the organism.
Oh, so I think I get it. The excess water, or the runoff, from plants have tons of different molecules dissolved into it, like the inorganic nitrates coming from fertilizer, which, due to their high solubility and less likeliness to bind in the soil, leaches into our water supply?
Exactly. And the nitrates will not evaporate, so they stay in the water until they are absorbed by an organism.
Wow.
As a matter of fact, several surveys prove that there has been a steady increase of nitrates found in our drinking water. This poses a serious threat to the human health and especially, and even that's the worst part, to babies. So why are nitrates in our water bad and harmful for us? Well, as nitrates enter our body, as soon as they come into contact with saliva, 5% of the nitrates, which are not harmful, are converted into nitrites, which are harmful, which I'm going to explain later on. But as soon as the nitrates enter our stomach, there are several bacteria to be found that live in our stomach that start converting further nitrates into nitrites. And as the nitrites come into contact with hemoglobin, protein that is found in our blood, which we use to transport oxygen from our lungs to our various parts of the body, reacts with nitrites, they form methemoglobin, a protein which is not able to release the oxygen taken up by the lungs. The lack of functional hemoglobin in our blood leads to methemoglobinmia.
Many Facts with Dr. Harmon Kinda.
Hi, my name is Dr. Harmon Kinda, and today I will talk to you about methemoglobinmia, what it is and how it affects the human body. So what is methemoglobinmia? It's a blood disorder in which abnormal amounts of methemoglobin, which is a form of hemoglobin, molecule in the red blood cell, that distributes oxygen to the body, and when there's a deficiency of that. This means that the body cannot receive enough oxygen in the blood, which is bad for the system. Now, please note that humans can accept nitrates and nitrates in their body. So in this case, the body can accept 10 parts per million of nitrates, while only 1 part per million of nitrites. So this shows that we can accept it, but nitrates have a more dangerous effect on the body. So acquired methemoglobinmia is more common than inherited methemoglobinmia, and people acquire this when they are exposed to certain chemicals such as anesthetics, benzene, antibiotics, fertilizers that contain nitrates and nitrites. People have symptoms of these too, such as bluish coloring of the skin, lack of energy, headache, fatigue, and shortness of breath. If you do experience any of these, contact a doctor right away. So now we'll get into the detail of this. How does methemoglobinmia occur? And what are the chemical reactions in the body? So red blood cells have 4 hemoglobin chains, and each hemoglobin chain molecule is made up of 4 polypeptide chains associated with 4 heme groups. The heme groups contain an iron molecule in the reduced or ferrous state of Fe2+. This form, iron can combine with oxygen by sharing an electron to form oxyhemoglobin. When it releases oxygen to tissues, and iron molecules are restored to their original ferrous state. Hemoglobin can accept and transport oxygen only when an iron is in its ferrous or Fe2+ state. Now we know that hemoglobin loses an electron and becomes oxidized, which is converted to its ferric state of Fe3+, or methemoglobin. Now, methemoglobin lacks an electron that is needed to bond with oxygen, which in return means that it can't transport oxygen. So red blood cells are exposed to various oxidant stresses, and blood normally contains approximately 1% of methemoglobin levels. And low levels of methemoglobin are maintained by two mechanisms the body has: a protective mechanism against oxidizing agents, and a mechanism against methemoglobin formation using two enzyme systems. Now enough about that. We'll go into just the summary of this. So oxidization of iron to ferric state reduces oxygen carrying capacity of hemoglobin and results in a functional anemia. So this is just bad. The body can't accept that much oxygen anymore. And methemoglobinemia results in impaired oxygen delivery, and this can result in deoxygenated blood, which gives a bluish undertone on the skin, but when you look at the actual blood, the blood turns a darker red color. And this is also known as blue baby syndrome. A baby's skin has a more bluish undertone, which is where the name has been derived from. So this has been Dr. Harman Kinda for Medifacts.
Tonight on KGWX, we are going to talk about three main things occurring in our Canada's environment. First, Methemoglobinmia is on the rise, especially in our infant population, increasing our amount of blue children. Secondly, fertilizer and agriculture stocks are at an all-time high due to our great growing season. Lastly, our potable water is becoming more and more infected every day, and Canada is rated one of the worst countries, worse than Nigeria. Thanks, and good night on KGWX.
So to recap what we've learned so far, fertilizer plus overwatering leads to runoff. Some of the nitrates in runoff are converted to nitrites when they enter our stomach. Nitrites react with hemoglobin, an oxygen-carrying protein in our blood, to form methemoglobin, a non-oxygen-carrying protein in our blood. Too much methemoglobin causes methemoglobinemia, a blood disorder in which the blood cannot carry oxygen to the various parts of our body.
As I mentioned before, babies are more susceptible to a disease called methemoglobinmia. But why is it so? Well, the baby's stomach has a higher pH level than the average adult human one, which means there are less acids contained in the baby's stomach, which kind of gives a more ideal environment for nitrate converting bacteria to survive in the stomach. These bacteria convert the nitrates that enter the baby's body through water, for example, into nitrites, which are harmful to the baby's body. But why are they harmful? Well, as soon as nitrites come into contact with hemoglobin, they can react with it and form methemoglobin, a protein which is, unlike hemoglobin, unable to transport oxygen to the baby's body. So, as the babies are in a very early stage of life and they're still developing various body parts such as brain and liver, this can lead to a lack of oxygen, can lead to very serious defects in their later life. As more methemoglobin is present in the baby's blood, the skin color takes on a kind of bluish undertone. Because of that, methemoglobinmia is also known as the blue baby syndrome.
Question 1. What is one way that nitrites and nitrates enter our water drinking system?
Question 2. Which protein molecule is not able to carry oxygen?
Question 3. what is the disorder we have been talking about today?
Question 4. Why are infants more susceptible to methemoglobinmia?
When you need some water that is nitrate free, you add a little filter and you'll be methemoglobinmia free. Tonight on K-Green. That's all for tonight in Canada on Methemoglobinmia. Methemoglobinmia.
Methemoglobinmia.
Something.
I have no idea. Methemoglobinmia.
My name
Wait. Okay, do it again.
It's great. It increases It increases It increases my growth rate and my metabolism. Shut up!
Question 4. Why are infants more susceptible to methemoglobinmia?
Question 2. What protein?
Shit!
Well, space, stomach content.
Sorry.
So, as
If the pencils affect your brain.